All right, so here's the first thing I'm going to do. We're going to do just the top where it says write the formula for the following. All right, so here's the first one. So zinc. I have no idea why that pen is so heavy. Let me change that. All right, so zinc oxide. Ryan, you do know this question, so I'm going to ask you this question. You know the answer to this question. Why are you freaking out? Is zinc a metal? Yes or no? Maybe you don't know this answer. Will you pass out periodic tables for me? Do you mind? So it is a metal, right? All right, Ryan. So since you told me it's a metal, now oxygen, right? Oxide, oxygen. It's a non-metal. So Ryan, so what type of bond are we working with? Come on now. Which one? Ionic. All right, so that's the deal. So Emma, since we're working with ionic, what will you not see anywhere in this? Prefixes. Very good. So there are no prefixes in this, but what we've got to do is we've got to take this thing and we've got to turn it into the formula. So here's the major thing that I need you to understand is ionic, and you may want to write this down. You've got to know the charges. That's going to be super crucial to understanding this. All right, so Gage, he's already told me that zinc's a metal, but is it a transition metal? Yes. Well, where in the world are my Roman numerals? It is an exception. Very good. And I've asked you to memorize 3 exceptions, and zinc is one of them. What is the charge on zinc always going to be? Anybody? 2 plus. Very good. So we're going to write Zn 2 plus. That's it. Okay? Now, so we got zinc taken care of. Now, Massimo, oxide is what element? Oxygen. And oxygen has a charge that never changes. And tell me how you know the charge before the charge. How do you know what it is? Very good. And what group is it in? 16. So what is the charge on all group 16 nonmetals? Very good. And again, that's where that red part comes in. You just got to know that. There's no other way that I can explain to you other than facts. You know, there is one way you can possibly remember, and Ryan, this is what you kind of need to pipe in on this, is it's in group 16, right? How many valence electrons does it want to have? It wants 8. Well, how many more does it need? Well, that's why it's 2 negative. Okay? All right. And I've taught you 2 ways to figure out what the formula is. One way was the math way, and what did we set those numbers equal to? Set them equal to 0, or the simple way to me was the crisscross method. But the third and simplest way is what do 2 positive and 2 negative do? They cancel each other out. So what's the final formula? ZnO, and that's the answer. That was pretty simple, right? Not hard at all. Now, if you did the crisscross method, I do want to show you this because we've talked about it. If you pulled that down and you pulled that down and you had Zn2O2, why could you not leave it like that? Because it's not reduced. Okay, you have to have it reduced. It's got to be in the simplest whole number ratio. All right, let's look at B. Chromium 2 nitrate. All right, we have not done one like this yet, and so you're going to learn a little something new today, but it'll make sense. First of all, what is the symbol for chromium? Cr. Ryan, I'm going to ask you this question again. Is chromium a metal? Yes. Okay. Sharon, is it a transition metal? How do you know? Simply by just looking at the name. Roman numerals. That is the key identifier that lets you know that it is a Roman numeral. And here's one of the major aspects. What does this refer to? It's the charge on the Tm. What is Tm? Transition metal. So chromium has a charge of what? 2. Now, I have a second question for you. Is it positive or negative? Positive. Remember this little phrase. Cats come first. That's how you know. Now, what do I mean by cat? Cation. Okay? Now this is the part that you've never seen before, and I want you to write it down just like I write it. Write it just like that. Try that again. Polyatomic. No, it is not a polynomial, it's a polyatomic. So here's another little phrase that I like to say. Let me change it to this. How do you spell is it parentheses? E-S-E-S or E-S-I-S? Parenthesis, is that right? Or is it E? I think it's E. I think it's E-S. Parentheses. Okay. Alright, we'll go back with a parentheses. That just looks like parenthesis. Whatever. We've got all those P words. Parentheses, protect, polyatomics. Parentheses. Ooh, who was right? The guy who doesn't know how to spell. There is one thing that I don't do well, and that is spell. No, I can do that. I can do phonetics. All right. So parentheses protect polyatomics. So here's what I need you to get. There's one thing outside of those parentheses that we're not protecting. And what are we not protecting? We're not protecting the charge. Because remember, what do we do with those charges? We crisscross them, right? So here's what we're going to do. We're going to take this 2, and we're going to drop it there. And we're going to take the 1, and we're going to drop it there. And I'm going to change pages, and this will make sense whenever I show it to you. But here's what the final answer will be. So the final answer is CrNO3,2. And again, what did those parentheses do to that polyatomic? It protected it. And here's how you would know that you made a mistake. And every year, I get a smattering of these throughout questions or answers. Without the parentheses, that looks like 32. And that just doesn't look right at all. That makes absolutely no sense. And the second one, the one in red, where did I come up with that 6 from? I just multiplied it. But here's the problem. Go back and look at the name. The name of this thing is chromium 2 nitrate. Is NO6 nitrate? No, nitrate is NO3. Okay, but like if I called Massimo Bob, that's not Bob. Okay, that doesn't match the name. Okay, so that's kind of what's going on there. So that's the wrong button. We use parentheses again to protect what's inside of it. I know you haven't. I know that. But let me give you one more example. What if we were dealing with this? And I'm going to use pretty much the same thing. If I had silver. Now this time, what would happen to the one positive and the one negative? They would cancel. So let me ask you, would you still have to protect it from anything? There's nothing back there, right? So when can you drop the parentheses? When there's nothing back there. So what you can write this AgNO3. Again, the only time you can drop the parentheses is when there's nothing back there. You're not having to protect it from anything. It can just it can be there. No, I will not count this wrong. It's kind of like one of those things, there's a right way and then a correct way. They're both right. One's just more correct than the other. Yes, sir. All right. So let's talk about that. So actually let me rewrite it so it's a little bit clear. So when we had CR2 2 plus NO3 minus. So ask me your question so I can refer to it specifically. All right, so here's what you have to do. These numbers have to be set equal to 0. You with me? So mathematically, if I've got 2 positives and I've got 1 negative, how many more of these would I have to have? I'd have to have 2 of them, right? So you're telling me I need 2 of these, correct? So watch what happens. I have 1 chromium and 2 nitrates. Does that make sense now? That's the math method. I promise if you go back and watch those videos, I have gone through every bit of that. What I have created is this method called the crisscross method, where you have to do no thinking. You just do. And it always works. Okay? Did I create the method? No, it's just my wording. People have been doing it for thousands of years. Yeah. It's just, I call it the crisscross method. It's like the things that Miss Folds does every day, people have been doing for thousands of years. They're just her words. Okay? All right. Now, this last one should be very, very, very easy. Ryan Howard, how do you know what type of bond it is? Simply by the name. I do C. That is the best answer, but just looking at the name, how do you know it's covalent? The prefixes. Yeah, the prefixes. So if it's carbon monoxide, how many carbons are there? 1. If it's monoxide, how many oxygens are there? Well, that was really difficult. Okay, that's it. That's the answer. You guys do, we do, and you do those 6 and see what you can come up with. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Remember yesterday remember that's the reverse crisscross process? Remember, if the charge on the metal is going to be your Roman numeral. But, for example, I'm going to go ahead and show you one, okay? In fact, this is we do A. You with me? Okay. First of all, what is SN? It's 10. Does it need a Roman numeral? Yes. We got to figure out what that is. Now, what would the second word be? Why is it not monooxide? Very good. So we need to know what this is. Well, remember, this comes from the charge. And remember, the charge sits right here. Really? All right, so we got to pull back, right? Got to pull back. Well, here's the deal. When I pull back, what 2 numbers did I just pull back? I pull back. So remember, so I have 1 plus and 1 minus. But the thing I taught you guys yesterday, that this is why this is the hardest part of all this is the hardest problem to do, is that number correct? No. And so what do you do to fix that? Yep. Multiply it times what it's supposed to be. And so that's why it's 10 to oxide. So does that answer your question? Okay. Like I said, that's totally different than what we were just working on, though. It is. All right. So calcium chlorite. Calcium. What is calcium symbol? All right. Well, let me actually write it. Calcium chlorite. So calcium is Ca. What group is it in? So it's a 2 plus. And here's where you got to recognize chlorite. That tells you it's a polyatomic. And how do we protect polyatomics? Parentheses. P. No, why not write P? ClO2, close it, and then 1 negative. Okay? So when I crisscross my 2, and I crisscross my 1, I should get Ca. Now, do I need to protect chlorite from anything? What am I going to be protecting it from? I'm going to be protecting it from that 2. So ClO2, 2. All right, B. Yes. I'm going to go ahead and tell you this on the test. I put 2 questions back to back. One of them is manganese and the other one is magnesium, just to see if you know the difference between the symbols. And I get it, people, every year they swap the symbols, and I do it on purpose to make sure you're paying attention. What is manganese? Mn. Let me show you something. If you ignore the A, what's the next letter? Mn. Magnesium is Mg. So it's whichever letter comes first. All right. Did you really? We'll have people earlier messing that one up too. All right, so manganese 2. So where does that go? All right, every year I get this. Okay, every year I get that. So be very careful here. Whatever works up there, use it, utilize it, man. The Romans were superior people, so it's always got to be at the top. I hear you, boss. Well done. I like that. All right, now bromide. Now here's another little phrase that I've used in the past. So if when you play hide and go seek, you don't go in groups, right? You hide by yourself, which means bromine is going to be alone. It's not going to bring along its bros. Okay, bromate, right? Bromates, ha 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 ha. Okay, you eyed by yourself. So if it's eyed, it's the element by itself. It doesn't have any friends with it. Kind of like when you ate, polyatomic bromate, like you don't want to eat by yourself, so you ate with others. Ha 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 ha. All right, bromide. Just it's just one negative. Now, why is it just one negative? See? Very good. So group 17. So I'm going to do my crisscross thing. Now, why don't I need any parentheses here? It's not a polyatomic. I don't need to protect anything. So I've got MnBr2. Ryan, is you catching on to it? Nope. Okay. All right. Now, the next one should be really easy. Nitrogen trichloride. So how many nitrogens? 1 trichloride. Cl3. Okay, Cl3. All right. Copper 2 phosphate. Copper 2 phosphate. All right. So again, you ate with someone. So you gotta have some friends follow along phosphorus. So copper. Now again, what do we know about Roman numerals? What kind of people were they? They were superior people. I hear you, boss. I like that one. Okay. So copper 2 phosphate. We've got a polyatomic, so I got to protect it. PO4 3 negative. Okay. Now, again, when you crisscross these, did not think that was what was fixing to come out of his mouth. So you've got Cu3 P. Bob, right? Bob. Yeah, because it's 8. 8 and 8. Dude, you memorized those whole things twice. Not you. It doesn't matter. It doesn't matter. It's 1 extra, but the phosphide is PO3. Heck no. You've been memorizing them for months. I told y'all that since day 2 in this class. You have to have these things memorized. And y'all didn't believe me, and it's finally coming back to haunt you. I gave y'all that polyatomic sheet the first time, the second day of class back in August. 2 of them, twice. Day 2. Barium nitrate or trite? Barium nitrite. So, barium. Ba. What group? Okay. Nitrite. So what is that, Ryan Dismix? It's a polyatomic, right? All right. So NO. All right. So we got there. We got there. Ba. NO. 2. 2. Now, can you drop the parentheses in this one? No, because you got to protect it from that 2 that's out back. And then finally, C, krypton difluoride. So how many KRs do you have? 1, and how many fluorines? 2. I'm telling you now, and I'm going to go ahead and write this. Please do not be the person, I will mark this wrong. Do not be the person that writes this. Okay? And I get it, guys. I understand why that makes sense, because fluorine is F, but chlorine is Cl. I get it. I understand why people want to write the L. I wish it were FL. To me, it would make more sense. But and the other times it doesn't. I agree. To make consistency, it would be Cl, but it's not. I agree. Absolutely. Because you know why it's not a consistent science, and I mean this for real? Because there were thousands of people who worked on all this independently that didn't have a consistent, it was during different time periods, and so they all did it on their own. And so that's why it's not consistent. It was multiple. It's kind of like math. People use different variables for different things. Like we have different symbols, like Greek letters, because all the different people are using different symbols. So that's why it's not consistent.